Hello statistics student, this video is for chapter 8.3 part 2. We're still on the topics of confidence interval of a proportion. Proportion meaning the percentage of something of the whole population. So we would be using a sample, the sample proportion to estimate the population proportion. So we are working on this work problem where we say we want to know the percentage of household use Netflix. But when we count 500 households in a sample, 442 use it, which is 88.4%. But this does not represent the whole population. What is the population percentage? And then we use statistics and we find out that it could be as low as 86%. It could be as high as 90.7 or 90.8%. So usually we round to 3 decimal places, right? So we would want to do interpretation. Okay, interpret the confidence interval in non-technical term. Now, when we write the number out, we write it in decimal, right? Because it's like math calculation. But when we interpret in a number sentence, we usually use percentage, and it's usually in this particular format that we say we estimate. This is an estimate. Remember that with 90% confidence that the true proportion of all household, all for the whole population, whole population that use Netflix is between 86% to 90.8%. So directly interpret it from here and use percentage. The D part is, can we conclude with, it should be 90, with 90% confidence that, because we're doing a 90% confidence interval, right? So it should be 90. Yeah, it was 90. So that more than 80% of households use Netflix. So look at the interval that we have. The interval that we have is 86% to 90%. So 86% to 90.8%. So all these are possible proportion that use Netflix. So all of these are greater than 80%. 80% is here. So the whole interval is, so we say yes. Right? So these two kind of questions are very typical. They will ask you to write a statement to interpret it, and they will ask you to draw some conclusion. So another example, example 2, there is a samples of 1,487 adults. It shows that 43% have Facebook pages. I think that's kind of low. I think a lot of people have Facebook pages. This must be done in like 2015 or something, or 13. I think this book was written in 2013. So so that at that time it was kind of low. But right now I think it's 70 something percent. Find a number in the sample who have Facebook pages. So we need X, right? So if we want to do they use this to calculate the real proportion estimate, interval estimate, we need X. We have P hat in this sample, right? So X would be, because P hat is X over N. So X would be N times P hat. So we'll do 1487 times 0.43, and we round it to the whole number. So it's supposed to be times 0.43, supposed to be 639.41. But this is person, right? Adults. So cannot have a decimal number, so we round it to 639. Now we can use this X and N, which is 1487, to do the estimate at 95%. So remember, instead this, we need C level, N, and X. So if X is given, like in the first example, then we are done. But if X is not given, sometimes we would use P hat to calculate X. Okay, because 43% of this would be multiplying. So I have the answer here. Let's run it one more time. 0.95, 1487. 0.95, 1487. But then out of those is 639. Has Facebook pages. Evaluate is the error is 0.025, so it's quite good. Oh, I should talk about there's two intervals, right? Which one should we use? We use the first one, right? The second one is sometimes called the +4 method. We don't use that, okay? It's used in special situation where the sample size is really small. And yeah, if you're interested, the book actually talks about it. It's called the +4 method or Wilson score method. 0.404. Yeah, so after you round, it's 0.405 and then 0.55, 0.455. The error is 0.025. Okay, so you do the rounding for three places. Right, a non-technical interpretation, then we will say we are 95% confident that the true percent of adults who have Facebook pages are between 40 to 45%. Okay, so this is the real one. We don't know what it is because p-hat distribute. P-hat, is not always 43%. The one that you have is 43%, but we think the real percentage is between 40 to 45. Now, in the newspaper, they usually do not write this. They usually just write the point estimate. This is called the point estimate of 43%. But you have to say, now that you learn statistics, you have to know that whenever you read those articles about a study quoting a percentage, that is a point estimate. The real one should be in a interval estimate with the margin of error. Can we claim that less than 60% have Facebook pages? Is it? Is 40 to 45 or less than 60? Yes, because if we draw the number line, or you can actually just think about it. 40, is it 40 to 45.5? What is it? Is it 40 point what? 40.5. Yeah, 40.5 to 44.5. And then 60 is all, so these are all possible proportion, right? But 60 is here. So all of these numbers are less than 60. So we say yes. Since the whole interval's whole possible value is less than 60, less than 0.6, so we can say less than 60% of all adults have Facebook pages. The last things we want to do is just like in 8.1, we want to know if I want to restrict my error to a certain number, what sample size should I use? Okay, so remember the formula? We always go back to the formula we used to calculate the margin of error. It's z alpha over 2 square root of p hat q hat over n, right? So this is how we calculate it. So we'll just use, maybe I'll use the space over here to find what n would be if someone tells you, like your boss tells you, oh, tell me, you go do a study, but I don't know what sample size you're supposed to be, but I want the error to be a certain number. So what you have is earlier we would have the sample first and then we calculate error. Now we haven't done the study, but we want to find what sample size we should use. So we would use p hat q hat over n. Remember q hat is 1 minus p hat is the failure in the sample. So we want to solve for n, so we just square both sides just like before. E square is equal to z alpha over 2 square. And then this p hat q hat would be free from this root. And then we have n also free from the root. And then we just do multiply n on both sides. So this would be just z alpha over 2 square, p hat, q hat, no square though, because it was under square root. That's it. And then we say n is equal to divide this by e square. Z alpha over 2 square, p hat, q hat over e square. So we can figure it out. And you can see that e square, this is e square. E and n are inversely proportional. So when n increase, when you increase the sample size, error will decrease. And also n error, the error is also directly proportional to the z. So if you have a smaller z, then you have a smaller e. If you have a bigger z, you have a bigger e. So we have these written here, but we don't have to calculate it because statistics actually have a formula that can help us to do. So remember, the E is not what you calculate; it's a desired E. Now P hat Q hat is a sample proportion, right? So you say if I have a sample proportion, I have a E already. No, so this is an old sample proportion that you have. You are going to use this sample size to make a new one with this target desired E. So I call this desired E. So let me show you where to do you should know where sample size determination, estimate proportion. Look what they have. They have confidence interval that you have to provide. They have a margin of error that you have to provide. Now, these two are optional. Usually we don't give population size, but estimates of P is what you have before. If you have it, you put it in. If you don't, you just leave it blank. So if you leave it blank, then they would use a default of 0.25. That means they have a default of 0.5 and 0.5. So you would say if P hat is unknown, if you're doing hand calculation, then use 0.5. Q hat, if it's unknown, also use 0.5. If you are doing hand calculation, now that this is handling it, so you just don't provide it. So this example that I'm going to do is when I have a O estimate. Remember, this is an O estimation of P is 0.43, and I want to do a sample size estimation where the I want the margin of error to be only 2.1%. Because last time when I do this my margin of error was 0.25, and I find that it is too big, so I want to lower it. And I want to find out what sample size do I do. So I would say E is 0.21, the old time is 0.43, and I want 90%, so I plug it in 0.9. And I say I want my new margin of error. Remember, this is not percentage. It has to be in decimal. And my old estimate is 0.43. And then I evaluate. They will say, oh, use 1504 as the sample size. If you do 1504, you can see that it is a little bigger than the 14 something that we have, right? 1487. You have a margin of error is 0.025. And you can see that if you want it to be lower to 0.21, then you use a sample size of 1504. What about if I don't have a previous study? I just want to have a 0.021, and I don't know what my old, I just leave it blank. I haven't done any study, so I can just leave it blank. Don't provide anything. Yeah, I think if you do blank, it doesn't work. It has to be like totally deleted. Then you evaluate again. Is it 0.21? Yeah. Just assume that no study. So you will see that it is 1534. So they use 0.5 to do it. It's 1534. So that's all for 8.1. The only difference with 8.1 is estimating proportion, estimating percentage of something. So versus 8.1 and 8.2, they are estimating mean, a measurement. Okay, but in all cases, they use this. So you are just looking at whether you are doing proportion one sample or mean one sample. Okay, proportion one sample or mean one sample.